Welcome you all. In this lecture, we will discuss about the outlier treatment in deep learning. So, what is the outliers? Outliers in the generally, if we are taking any data or you are classified any information somewhere else like this, some data is far away from the our expected outputs. Okay, maybe this happens due to the misclassification or some there is a problem while collecting the data sets. So, whatever it is, you can simply call it as a this data becoming outliers. So these outlier data will create a problem while we are predicting the outputs. We are creating a model for this specific applications. So how to deal with this outlier data in deep learning? Let us discuss. Okay. If I'm coming to here, so simply the definition of the outlier treatment is a outlier is a data point that deviates significantly from the normal pattern in dataset. That I said it may happen due to the measurement errors or incorrect data labeling. Example, if I'm taking over here, this may be considered as a some dog. This may be considered as a some cat. Sometimes what will happen, so due to the misclassification, some this data point may be wrongly classified to the dog. So automatically this will appear like this. So this we can consider it as a outlier. So what we have to do with these outliers? So outlier can negatively impact on deep learning models by causing poor generalization and slow convergence, because we have a taken here if we are finding any errors, that is if we are taking mean square error or mean absolute error, then it will give a large error. In order to reduce these errors, we have to go to the updates of the weights and biases. It will taking much time because the loss function is very high. We have to reduce this loss function, so it is creating some problem and we are not converging towards the true solutions because of this wrong labeled data or incorrect collection of the data. So therefore, before going to classify the application, we need to do some treatment on this outlier data. So it can improve our performance of the model as well as correctly classified, as well as loss function. Obviously, it will be reduced. If you are smart, if the loss function is very very small, then within a sufficient iterations we will reach the converged outputs. That is updated weights and biases. Here there are two types of outlier treatments were there. First one is a jet score and another one is a interquartile range. So let us take a one example over here. You have a data set of house prices and some of the house prices are extreme outliers. So we need to identify and remove these outlier before training a deep learning model. So if you observe from the data, there are total 13 samples were there. Among the up to 210, it is in a close to the one range, and these two samples are far away. So intentionally we have given these three samples far away. But let us check whether does it will come under the outlier or not. So before going to deal with the jet score, so first we have jet score formula is the x minus mu by sigma. Mu is the mean and sigma is the standard deviation. So mu, all of you know that mu is the summation of all the samples, okay, by the number of samples that given 259.62, and the standard deviation is the sample minus mean whole square plus likewise all the samples we have written by total number of samples. So standard deviation is 144.32 we have obtained, okay. So I'm computing the z score for each price. If I'm computing 150 minus 259.62 by 144.32, you will get minus 0.76. Like this, all the samples I have computed over here. If you compare this one, all the samples are almost all, that z score is almost all in the negative, but for the three samples which are already discussed far away from our data set in the data samples, so got that 1.67 1 point. Generally z score if it is more greater than 3, then we have considered it as a outlier, but here there is no z score more than 3. So indirectly it is saying that there is no outlier of the data. But if I am considering these three as a outlier, okay, then I can reduce my threshold limit to the 1.5. So automatically these three samples are outlier data having high score, so indicating they are potential outliers. So after removing this one, our new data set become like this. So this data we are going to train for the using deep learning models, okay. And importance of outlier treatment in deep learning. So automatically removing outlier improves model accuracy and generalization. I said already due to the far away from the data, incorrectly classified, incorrectly labeled data, not classified, incorrectly labeled data will give a wrong results, and the accuracy might be reduced. So this can be reduced by using these outlier treatments. In neural network, cause unstable weight updates. How we are weight updates are changing miss the last five, because the data is these three outlier data is far away from our samples, and it takes huge number of, that is a anyway many number of times need to update the weights, or sometimes to get to reduce the loss, weights are increased much in the order. So therefore these problems can be faced while updating the weights and as well as biases. This can be avoided if I am using the outlier treatments. Okay, and another one is the interquartile range model. So here see two quartiles we have to taken, that is a formula for this one is simply your Q3 minus Q1, okay, interquartile range. So first quartile is at less than 25% of the data, and third quartile range is 75%, less than 75% of the data we have to consider. Okay, high here is simply the difference of here also same data I have considered, and the first quartile n is the here 13 samples already I have said. So n plus 1, that it is appear 3.5 for the quartile 3, 3 into n plus 1 by 4, so it appears 10.5. Okay. First, if I am considering 3.5 means this is the first one, second one, third one, and fourth one. 3 point in the middle it is asking. So average of these two can be taken like this: 158 plus 159 by 2. 158.5 is our Q1. At the same time, 10.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10.5. In between these two, we have considered the average value. Q and this Q3 minus Q1 is becoming a 196.5. Our interquality quartile range is 196.5. Okay. Now compare the outlier boundaries. So lower boundary is the Q1 minus 1.5 into IQR, that is appeared. Okay. And upper bound is the Q3 plus 1.5 into IQR. So this appears 649.75. So as per, if you are considering this one, upper bound is 649, but actual data is here, it is 530 only. Here the IQR saying that there is no outlier data. At the same time, I said Z score also saying that there is no outlier data. But as of my assumption from the data itself only, because a very small number of data set, the data set is consisting very limited number of samples, I observed that these three samples are far away from this one. So that's why I have taken the threshold from here. Then I remove this. The same way, if I'm considering here, if I'm taking 200 minus 210 by 2, okay, if I'm calculating, automatically this value will reduce to the 90 or something else, okay, 90, okay, 105, right, 105, and after calculating automatically, our results will get less than this one. This range will come to below the 500 automatically. These three values can be neglected in the subsequent procedure. Okay, that is up to the application. So depending on application, how we are how we are doing the treatment of the data. So we, as per the formulas, if I am go properly, then there is no outlier data over here. But for my assumptions, what I did, I by observing the data, I assumed that these three samples are outlier data, and I have taken appropriate thresholds and deleted in the subsequent stages. Here itself also, instead of 10.5, I am taking 10 only. That means up to here, if I am taking automatically, then your answer will be same like this. If I am taking 10, then automatically this will come. This the data need to be considered, and this data need to be deleted before going to the next stages. So this is the outlier treatment. So what is the conclusion over here is simply, if we having a doubt, example, if we have wrongly collected the data or wrongly labeled the data, then the outlier data will appear in the data sets. So these outlier data will create a problem while classifying our model. It may reduce the accuracy. It takes more time to update the weights, and it having some different problems. Okay. Thank you. If you like the video, please click on the like button.